Hey, this is Math 7, Unit 7, Lesson 15, Distinguishing Volume and Surface Area. Again, these are different things, right? Volume is going to be that space kind of inside of an object, and surface area is talking about the area that covers something or goes around an object. Okay, so the first question here is really something you talk about with your class today, where I want you to have a discussion about kind of the differences between volume and surface area. So that's something you probably did together, and I'll let you have that conversation on your own. Okay, I'm going to move on to 15.2. Coming back to our box of chocolates again. All right, it says the other day you calculated the volume of this heart-shaped box of chocolates. All right, and that was great fun. The depth of this box is 2 inches. How much cardboard is needed to create the box? All right, so what we did last time is we first of all we figured out what the area of this shape was. And just to kind of go back on our notes here, we knew that the surface area was 40 inches squared. That was the surface area of this shape. So we know right away that we're going to have kind of the base plus the base, right? And that's going to be together. And then we're going to do plus what we did before is we've been doing the kind of the perimeter times the height is what we were doing before. Okay, so that's what we've been doing to solve this so far. So far we know we have a 40. That's pretty easy to do. We got a 40, and we have another 40 based upon our information from a prior lesson. And again, this should be in your notes from a couple lessons back. Okay, so how about the perimeter height? Can we figure that out? Looking at this shape right here, we know that this has a length of 2, which makes this have a length of 2, and then we have all of these diagonal lines there, don't we? So it creates a little bit of a problem for us. We don't actually know what these lengths are going to be looking at this shape like that. You're going to need to ask for some other additional information to be able to find out the perimeter there. Okay, so if you're in class, your teacher gave you some information, that was helpful because otherwise you wouldn't know. This has a length of, we can see the 5 and the 4, but I don't know what that diagonal is going to be. There is a way to solve that diagonal, but it's not something we've talked about yet in 7th grade. You'll learn that more in 8th grade, okay? There's a way to figure out what those diagonals are going to be equal to. But for now, the missing information is like as follows. These long ones have a length of 6.4. So 6.4. These short ones each have a length of 2.2. 2.2, 2.2, and 2.2. So our perimeter is going to be all these things added up together. So we have 2.2, and we have 4 of those. Then we have 2 regular 2.0s. Then we have a 6.4 and a 6.4. So that's going to be our perimeter, which is 2, 4, 6, 8. And 8 plus 8 is 16. Carry the 1. Then 2, 4, 6, 8, 10, 12. 12 plus 12 is 24, plus 1 more is 25. So that's our perimeter. Okay, so we're going to add that to our perimeter, which is 25, times our height. And it says the height in this case here, or the depth, which is the same as the height of the box, is 2 inches. So 25 times 2. Or sorry, 25.6, sorry, times 2. So we continue this process here. What would we say? We would say we have 40 plus 40 is 80. And we're going to be adding that to 25.6 times 2, which is 51.2. And then we add those things together, we end up with 131.2. And that again would be inches squared because we're talking about surface area once again. All right. So it can be done, you just had to have some extra information to be able to solve that there. And again, it's just simply going to be the base plus the base plus our new thing, which is the perimeter of that shape times the height, like kind of unrolling it out to make a long or big rectangle there. And that's how we work out that one right there. Okay, so the next activity is a card sort that you can do in class with your partners there. to determine whether it's a surface area or volume type of problem you're looking at there. And then let's look at activity number 4. It says in activity 4 that a wheelbarrow is being used to carry wet concrete. And here are the dimensions. So that looks like what? This looks like the base of an object, doesn't it? Okay. So what volume of concrete would it take to fill up that tray? So volume is going to be our surface area, or sorry, our area of the base times the height. We can tell the height right here is going to be that 70 because it's just going to be this face right there that we can see. Right? That's our base, and it's going to be that long. So we know the height is 70. Now we need to find the area of the base. They gave us this nice picture here to help us out with this. So we have a height of 66 and from here to here, and we have a distance of 34 there. So this space is going to be 1/2 of the base times the height, and I wrote this backwards, sorry, 1/2 of 34 times 66, doesn't matter, that's okay. So 1/2 of 66 times 34 is actually equal to 1,122, and you can use a calculator to figure that out if you wanted to, but that's what goes right there. Over here, I have another trapezoid shape, so I'm going to go ahead and draw a line right there. I'll chop it up right there and decompose a little bit more, okay? So by doing that, I know I have a height of 66, and I have a distance here of 40. So 40 times 66 is equal to 2,640, and that's what goes right there. And then over here, I have still a height of 66, and my base though is not 106, it's 106 minus 40, which is going to be 66. So in this triangle, I have 1/2 of 66 times 66. So that actually becomes 33 times 66, which is 2,178, and that's what goes right there. So combined, my base is going to be 2,178 plus 2,640 plus 1,122, and when I add that up, I get 10, carry the 1, I get 8 plus 6 is 14, carry the 1, 6, 7, 8, 9, and then we have 5,940. So 5,940 times my height of 70 is going to give me an actual volume of 415,800 centimeters cubed. So again, just a lot of perseverance here to decompose the shape and find the missing segments that go there and get that all worked out. A lot of places where you can make a calculation error, and I tell you what, when I do it, I make errors too, and that happens. You just kind of go back and double check, and that's okay. Just find out what your mistake was at. This is my second time, third time doing the problem, so the first time I did it, I had to really think about it. It makes it seem really easy when I take it step by step, but again, that's me thinking about it and thinking about it some more and breaking it down to some small steps for you guys to follow. All right. Number 2, it says, after dumping the wet concrete, you notice that a thin film is left on the inside of the tray. What is the area of the concrete coating the tray? So we're talking here about surface area. Okay? Remember, there's no top. So what we're going to do is we're going to find the surface area of this object, and then we're going to have to remove the top, basically, is what we want to do. So surface area we've done by finding the perimeter of a shape and then kind of unfolding it, and then adding that to the area of the bases. So we have our base plus our base plus the perimeter times the height. That's our basic. In this case here, our base was 70, and we have another 70, and our perimeter is going to be all these numbers added up together. So for our perimeter, let's do it over to the side. We have 106, we have 34, we have 74, we have 40, and we have a 93. So that becomes 10 plus 7 is 17, carry the 1, Here we have a 16 plus 4 is 20, plus 3 is 24, so 2, and 2 plus 1 is 3, so 347. 347 times our height, and our height is still going to be 70. So 70 plus 70 is 140, plus 347 times 70 is 2,000. Well, it's actually not 2,000. I'll get my calculator out real quick. Why? Because I did a shortcut there in my notes. So 347 times 70 is equal to 24,290. And we're going to add that to our base, which is 140. Something's a little funny there in my notes. 1 second here. I see 106. I see a 40. I got a 93. I got a 34. I got a 74. Okay, so surface area, we have a base, and we have a base. And our base is going to be the area. Oh, I did the base is not. Silly me. The base is going to be the area of the other part. Oh, my mistake. So our base is not 70. My goodness. What was I thinking? See what happens? I get in a hurry sometimes. Our base was actually this number right here, wasn't it? It was 5940. 5940. 5940. That's our base. That's our flat area. Sorry about that. And then, so 5940. 5940 plus 5940, which is 11,880, plus the area around that rectangular shape. So 24,290 gives me 36,170. Is where I'm at so far. 36,170. But now I need to take off, in a sense, the lid. That lid, top part right there of that lid, is 140 by 70. 140 by 70. So that becomes 8,298 is the area of that lid area. So let's take that away. And we have, and then 2, 15, 6. So you put 26,370, which is not what I got the first time. So I'm not sure if I did right necessarily. I don't have time to go back and look at it 100 times, but that's what I got this time, because I have the area of the base, which is that and that, which is 5940 based upon the previous work here. And then I did the perimeter and added the perimeter up times the height, which was 70, and that got you that number there. And then we subtracted the lid, so to speak. Okay, so it does work out. Hopefully that's right. If not, that's okay. I'm sorry. You can comment and tell me I got it wrong. I get that every once in a while. It's okay. All right, let's pause there. Do our homework and come back and check it. All right, here we go, homework time. So here is the base of a prism. If the height of the prism is 5 centimeters, what is the surface area? Okay, well, let's first of all find the area of the base. All right, I'm going to decompose it. So here I have 3 times 2, which is 6. I have 3 times 2, which is 6. And here I have 8 times, now I use a 2 right there, so this makes this a 3. I have 8 times 3, which is 24. So the area of the base is going to be 36. That's the base. It's 36. So if the height is 5, what's the surface area? All right, so the surface area is going to be, in this case here, our surface area is going to be our base, right? It's our base plus our base plus our perimeter times the height. So our base is 36 plus the 36 plus the perimeter. Perimeter, let's add them up. We have 5 right? That's a 5. Here's another 5, so we're at 10. Here's another 5, so we're at 15, 20, and then another 10 makes 30. So our perimeter's 30, and our height we said was 5. So that's 150. So equals 150 plus 36 plus 36 is 72. So that's going to give us a grand total of 222 centimeters squared. There's our surface area. If the height of the prism is 10, what's the surface area? Okay, well our base stays the same, so our base plus base is still 72. But now we're going to add to that then our perimeter, which is 30, times our new height, which is 10, which is, so that'd be 300. So we get 300 plus 72, which equals 372 centimeters squared. When the height doubled, what was the percent increase for the surface area? Okay. Oh, I didn't do the volume, I'm so sorry. That's just the surface area. So let me back up real quick. So volume here is going to be the base, 36, times the height, which is 5. And 36 times 5 is 180 centimeters cubed. And this one here, we do our base, which is going to be 36 times our height, which is 10, and that equals 360 centimeters cubed. So sorry. So we have our volume and our surface area. So the increase for surface area. Alright, so we went from 222 to 372. So I need to find out the difference first of all. So 372 minus 222, which is going to be 150. And I do 150, the difference divided by the original. So 150 minus 222 gets you about 67%. That's the surface area increase. Now for the volume increase, same idea. You went from, we had 360, we had 180, the difference there is 180. So we do the difference minus the original, and that equals 1. Well, 1 is the same as 1.00. As a percentage moving it over there, it's 100% increase, meaning we're doubling it, 100% increase, that's what you get there. So surface area is 67% and volume is 100% increase because it doubled. Alright, select all situations where knowing the volume of an object would be more useful than knowing the surface area. So looking for volume. Determining the amount of paint needed to paint a barn, that is around the surface area. Monetary value of a piece of gold jewelry, you're going to want to kind of find out how the volume of that, what that volume is going to be. Filling an aquarium with buckets of water, so you're filling it up is the volume. Wrapping paper, going around something is surface area. Packing watermelons for shipping, that's a volume. Charging company or ad space on your race car, you're wrapping it up, that's surface area. And measuring gasoline left in the tank of a tractor is volume. Alright, let's see. Han draws a triangle with 50 degrees, 40 degrees, and a 74 as shown. Can you draw a different triangle with the same conditions? 50, 40, and 4. Can we draw 50, 40, and 4 with different things? I'm sure that we can. So the answer would be yes. So let's go ahead and make our 4 right here. 1, 2, 3, 4. Okay, I'm going to make a 40 right here. Let's make it a, 40 right here. Okay, so I'm going to make this nice long line, and this one has to be set as 4. This line can be as long as I want it to be, right? As long as I want it to be, or short as I want it to be. So there's 40. And then if I want to make a 50, right, knowing that I had before a 50 and a 90, I can make this one my 90. And if I make that my 90, here to here, then what I'm left with is this is my 50. And there's my 90. Is it the same? Nope, it's different. Instead of having the 4 between the two angles, now I have the angles over here and the 4 out there. So yes, it's possible. Number 4, angle H is half as large as angle J. Okay, so J, I'll do this. So H is equal to J times a half, right? J is equal to 1/4 of K. 1/4 of K. And then K is equal to 240. So now, what's the measurement of angle H? So we go here. So 240 and 1/4 of 240 is going to be equal to 60, right? So J is 60. And then half of J is going to be 30. And our last one. Colorado state flag consists of 3 horizontal stripes of equal height. The side lengths of the flag are a ratio of 2 to 3. So this whole thing is like 2, and the top part is 3. The diameter of the gold disc right here, diameter is the same as the stripe. Alright, so what percentage of the flag is gold? So a couple things to do. We have to find the area of that, and then we're going to have to divide that area by the area of, so the area of the circle divided by the area of the whole flag. Okay, so if this whole thing is 2, then that means that this is going to be, I have to make this into a ratio. This is, there's 3 parts, so everybody gets part of it. I have to divide the 2 by 3, right? So I get 2/3 all the way through, because 2 plus 2 plus 2 is 6, and 6 divided by 3 is 2. So every size there is 2/3. I don't have a unit for that, I'm just calling it 2/3 just there. Then the diameter of the circle is what I'm looking at here, and diameter is going to be equal, in this case here, to 2/3. I don't know what the 2/3 is, but it's 2/3. So to find the area of the circle, area equals pi times the radius squared. Now, I don't have a radius, I have a diameter. So I need to turn that into a radius. A radius is going to be half, right? Half of the diameter, half of 2/3. Half of 2/3, reduce, equals 1/3. That's my radius. So I have area equals pi times 1/3 squared. So 1/3 times 1/3 is a 1/9. So that equals what? Pi over 9. So that's what my area is going to be for that space right there. But I want to find the area of the percentage. So that's the area of the circle, and what I want to do is I want to divide that by the area of the entire flag. Well, the flag is on a ratio of 3 times 2 is 6, so I do 6 over 1. I could write this another way. I could write this as pi over 9 divided by 6 over 1. And so if you want to think of it this way, I can rewrite that as pi over 9 times 1 over 6. So I end up with pi over 54 for my answer. A little interesting, kind of a fun little problem to do using what you know. Alright, that's it. We'll see you next time.